All right, I've got a question in Unit 4, Lesson 5, Part 2, and this is question 21. It's a ladder question. It says a ladder is 10 meters long against a vertical wall. So here's my ladder. Because the ladder is 10 meters long, it's a constant. So we need to keep that in mind when I go to solve the question. If the foot of the ladder is moving away at 2 meters per second, so that means that in the, I'll call that the x-axis, dx by dt, this is a rate. It's 2 meters per second. And the foot is 6 meters away from the wall. So that is telling me that change in rate, the 2 meters per second, is occurring when it's 6 meters away. We want to find the rate of change of the ladder when it's by what it's moving down by. So that means we are looking for dy by dt. So we want to know how fast is the top of the ladder falling. So this is question for part A. Right angle triangle. All right, so we are going to use Pythagorean theorem here. Equals h squared. Now I'm going to put in any constants. So x squared plus y squared equals 10 squared. And when we go to take that derivative, 2x dx by dt plus 2y dy by dt. Derivative again, this is where people, if you're going to make a mistake, it's going to be right here. It's remembering that the derivative of a constant is 0, so there is no dh by dt because the ladder is not changing length. From there, the 2's will cancel out, and I said I'm looking for dy by dt, so I'm going to isolate. So that means I would have had to move the x term to the other side, and it makes sense it's going to be negative because the distance above the ground is decreasing, so it makes sense that that is true, and it's going to be divided by y. So I have all my information. I know x is 6. I know dx by dt. I do have to find y, so I will have to use Pythagorean theorem here to find it. So to find y, x squared plus y squared equals 10 squared. So x 6 squared plus y squared equals 10 squared. So that means y, 100, take away 36, 64. So it is one of our special relationships with the Pythagorean theorem. So I know y is 8, and I can use that information to finish the question. So negative 2 dx by dt, oops, sorry, x was 6, my mistake. So 6 times 2 over 8. If we were to reduce that, 2 makes that a 4, makes that a 3, so we get negative 3 halves meters per second. So therefore, top of ladder is sliding down at 3 halves meters per second. All right, so there's A part. B part, it wants to know the rate of change of the slope. So this is finding if m is slope, we usually use m to represent slope. So we're looking for dm by dt. All right, that's what that question's really asking us. So we need to find a slope equation. And really the only slope equation you know is from your grade 9 course, where slope equals delta y or delta x. Delta y and delta x are just measurements of the side of the triangle you created to find the slope. So these are going to be variables because it depends on when we're taking a picture of this situation. Because our y and x, because the ladder is sliding, our x and y values are changing, which means that these will be variables. And if they are variables, we need to treat them as such when we take a derivative. So I'm going to multiply it up to make it m delta x equals delta y. Just because I don't want to use quotient rule, I'm going to use product rule. So derivative of m is 1 multiplied by dm by dt delta x. So I took the derivative of m plus the slope and d delta x by dt equals d delta y over dt. So again, delta x and delta y are variables. So we're looking for dm by dt. So I'm going to isolate So that means I would have d delta y by dt minus m d delta x by dt divided by delta x. So we know some of the measurements already, okay? We know at that point in question, so it says the slope of the ladder at in that situation. Well, in this case, we know delta x, the size or length of that triangle we know is 6. D delta y by delta t, so how much is the y side of the triangle changing? And we found that to be -3/2. So -3/2 minus, what was the slope at that point? Well, the slope is delta y over delta x. So we know it was 8/6. So 8/6. What was the x changing by? The x was changing by a value of 2, or delta x over delta t, so this ladder was sliding out. So that's what it looks like. So if we simplify this, so I know my second fraction, it's going to be -8/3, and if I want the first fraction of a 3, I'll have negative, multiply, oops, that won't work. I was hoping to make this such that it's easy. So you can use your calculator here, but at the bottom, the denominator will be 6/6. So that means I'll have -9 minus 8 times 2 is 16. So that means in the denominator I'll have 36. Okay, and -9 take away 16 is -25. And that's a measurement, dm by dt. It's a measurement of slope, so it too is meters per second. Actually, it'll be unitless, so it'll be 25/36 per second. All right, so there we go. That definitely, the second part's a little bit more challenging, but at this point in the game, you need to realize that any equation that you were comfortable or know from before, from any of the courses, grade 8 or 9, 10, 11, you can now take the derivative of to find information that you're looking for. So if you have any further questions regarding number 21, let me know, but that is how the particular question works.